Welcome back, mathematicians. This example or this lesson is on real-world algebraic inequalities. The handout for this one is another 3 examples. I have them in color here, but you're going to have them in black and white. Again, what you're going to do is you're just going to cut them out, okay? And then we're going to solve the problems in our book. You don't have to cut along the dashed line. You can just kind of cut out around example 1, example 2, plus the picture, and example 3, and we'll try to fit them in the book. Our first example says the average of 70, 75, 83, 80, and a fifth number is at least 80. Describe the value of the fifth number. So average, as you've talked about in statistics, hopefully, is the mean. It's when you add all of your numbers up and you divide by the amount of numbers that you have. And it's just a representation of kind of the middle, right? Your average score. So that's what we're going to do here. We're going to find the average of 5 numbers, but we don't know what the fifth number is. Though we are given some information. So let's dive deeper into that. We'll use cubes, so we'll circle our numbers. We have 70, 75, 83, 80. I'm going to circle those just collectively because it's a little bit easier. Okay, and then a fifth number. I don't know what the fifth number is, but I know it is a number. Okay. Underline the question. It says to describe the value of the fifth number. Box in any key information. So there is one very key information, and that's this word at least. Okay, at least represents not an equal sign, but an inequality symbol. And so there are 4 to choose from, right? There's less than, greater than, or you have the or equal to's. So at least 80. So could it be 80? Yes, right? So we know it's going to be an or equal to. So we know there's going to be a line at the bottom. And now it says at least 80. So could it be 81? Yeah, right? So that means it has to be greater than or equal to 81. And that makes sense because say if you are trying to find the average of your test scores for the year, you probably want to know what you need on a 5th test, right? To get at least an 80 as an average for your grade for the term. So this is kind of a typical question. It's one that in high school you'll get, definitely in college, when you go up to towards the end of the year and you want to say, okay, what do I need on my last test, my 5th test, so that I can at least get an 80 in the class. Right, that's a typical question where this would come up. So we're going to label our unknown. We're going to say let x equal the 5th number. And now we're going to set up an inequality. So I'm taking the average of 5 numbers. So I'm going to write those 5 numbers down. I have 70, and when I take the average, I add them all up. So 70 plus 75 plus 83 plus 80. Now it says there's a 5th number. I don't know what it is, but I've just labeled it as x, so I'm going to use x. Okay, and when you take the average of 5 numbers, you add those 5 numbers together and you divide by the total number that you're adding. So it's 1, 2, 3, 4, 5 numbers. And I want that to be at least 80. So greater than or equal to 80. And let's shorten this up a little bit. Let's combine these like terms here. Okay, and it's really important to understand that it's not just these 4 numbers being divided by 5 or being divided by 4 for that matter. You're dividing the whole. Okay, so x is still in your numerator. Okay, so we can't just get rid of the 5 or separate it and take the x out and put it on the side. All we're doing is we're making this numerator look nicer. So when I add these numbers together, I should get 308. So it's 308 plus x divided by 5 is greater than or equal to 80. And then I want to get rid of this 5, so I'm going to multiply both sides by 5. And by doing that, these cancel. Okay? So I'm not multiplying this by 5 and this by 5. Okay? I'm canceling the 5 out. And we're left with 308 plus x is greater than or equal to 400. Subtract 308 from both sides. My final answer is x is greater than or equal to 92. Okay, and again, when I'm given a word problem, I want to answer with a sentence, so I'm going to say the fifth number and you can say has to be greater than or equal to 92. You could also say is at least 92. I'm going to use their words, so is at least 92. And that's example 1. All right, my next example says Kelly goes to an amusement park with her friends. The admission fee to the amusement park is $4 and each ride costs 80 cents. If Kelly has only $25 to spend, how many rides can she go on? Okay, so when Kelly goes to the park, right, think about when you go to a park. You usually have to pay a fee to get in, right? And then you're asked to pay some sort of amount for each ride. Okay, so there's usually a fee, right? Initial fee to get in, plus some sort of cost for each ride. And if Kelly only has $25 to spend, kind of jump ahead a little bit, has only, if I box that in, that's another inequality, right? Can she spend $25? Definitely, right? So it's an or equal to. Can she go over that though? No. So it's got to be less than. So this is a less than or equal to 25. Okay, and I jumped ahead just a little bit so you can kind of see the representation of when you go somewhere, right? You have to pay a fee plus some sort of cost per ride. And let's see if we can fit these numbers into this kind of generic equation. So using cubes, we've got $4, we've got 80 cents, and we've got $25. Underlining the question, how many rides can she go on? We already boxed in some key information. Let's also box in cost, right? Each ride cost. Usually when you see the word each, that's going to mean multiplication. $3 each, $4 each. Okay, so that's kind of a key word. Eliminate any unuseful information. We don't really need the fact that she goes to an amusement park with her friends. And now we can solve. So it's going to fit these numbers into place. The fee is going to be the $4 that she used to get in. Right? Then we're going to be adding the cost per ride. So each ride costs 80 cents. So that's 0.8. And we don't know how many rides she went on, so that's going to be our variable. We'll call it x. And that's less than or equal to 25. So we're going to say let x equal the number of rides. And now we have an inequality that we can solve. So, one thing that I did quickly that you may have noticed and may have been confused on is this number is 0.80. When you're working with decimals now, when you're inserting decimals into an equation, get used to kind of taking away the 0 at the end, okay? So you obviously don't want to get rid of a 0 at the beginning because you're in the decimals. So 0s at the end you can kind of get rid of. So 0.80 is the same as 0.8 and just makes it look a lot cleaner. Technically speaking, you could put a bunch of zeros behind 8, right? And it would still come out to be 80 cents. So 0.8 and just kind of leave it like that. All right, let's draw a sign, draw a line down the sides here. And let's solve. So looks like I have a two-step equation. I don't have variables on both sides, so that's good. You don't have anything to simplify on the left. Don't have anything to simplify on the right. I do have some adding and subtracting that's happening, so let's do the opposites. So we're going to subtract 4 from both sides. And when I subtract my 4, I usually do them under the like term, right? So I'm not going to take 4 right here. I'm not going to show that here. I'm going to show it here. It's just a way to separate things more so you get less confused. I'm left with 0.8x, still less than or equal to 21. And now I can divide by 0.8 on both sides. Those cancel to 1. You get x less than or equal to 26.25. So how many rides can she go on? Because remember, we have to go back and we have to answer that question. Can she go on a quarter of a ride? No, right? No one's going to be on a roller coaster and then throw you off halfway up, right? When you're up here, no one's going to just take you and chuck you off because you didn't have enough money. So she can really only go on 26 rides, okay? So that's what we're going to say in our sentence. Kelly can go on 26 rides. And that's it for example 2. All right, our third and final example. Theo wants to join a gym. He calls 2 gyms and is given 2 different payment plans. For Gym A, he has a $100 new membership fee plus $35 per month. And Gym B, $75 new membership fee plus $40 per month. After how many months will Gym A be less expensive than Gym B? Okay, so we're not going to use cubes on this one because it breaks it down into a table already and it already categorizes itself for us. So we're going to use the information that we're given. So we're asked to figure out after how many months Gym A will be less expensive than Gym B. So less expensive is probably going to mean less than, right? So when is Gym A less than Gym B? Kind of, let's break this down into 2 different colors. So just like when Kelly went to the park, she had to pay a fee. When you join a gym, you usually have to pay a fee. Sometimes that's just for paying the office workers to put through the paperwork. Sometimes it's just because they want to try and think that they can make you pay more money up front if they think you're going to cancel ahead of time or cancel after a few months. So it kind of depends on the gym. So in this case, Gym A says $100 new membership fee plus $35 per month. So this per, again, means to multiply. And that fee is like a one-time fee. So when we break each of these down, Gym A is going to be some sort of fee plus the cost times the number of months. And when is that going to be less than Gym B's fee plus the cost per month? Okay, and this is something you're going to be using a lot when you get older, because you're going to want to figure out, especially with bank accounts, and we're talking about interest, and if you have a checking account and you have to have the minimum amount in this checking account, but you get charged a fee every month if it goes below this amount of money, that kind of stuff. Okay, you're going to want to be able to compare two different plans, and this is the best way to do it. So while up front it looks like Gym B, right, $75 is less than $100, that's a great deal, okay, because their fee, Gym B's fee, is $75, and Gym A is $100. But per month it changes. So Gym A per month is only $35. So that's plus $35 per month, and we'll say M. So let M equal the number of months. And Gym B was 75, okay, plus, and this one's $40 per month. So at some point, right, because these are different and these are different, right, at some point they're gonna change. It's not gonna be, one's not gonna be less than the other anymore, okay? There's either gonna be a bigger difference, okay, or there's going to be a change in differences. So let's take a look at how that works out. So we've got an inequality now. We've got 100 plus 35M is less than 75 plus 40M. All right. Now in this case, we're going to look at each side individually, just like our flip chart. Do we have anything to simplify on the left side? No. On the right side? No. Okay. Let's put a line down the middle. Do I have variables on both sides of my equations? I do. And here's the challenge. Which one are you going to move? Because normally when we think of solving inequalities, we like to keep our variable to the left. That's not always how it's going to work out, though. Me personally, I like to move the smallest variable to the other side. So in this case, if I move 35M over here by subtracting 35M from both sides, and I put that right underneath its like term, okay, those cancel. I've got 100 is less than 75 plus, not 40 anymore, 40 minus 35, which is 5M, okay? And the reason I moved it over here is because I don't like working with negative coefficients. So I moved the smaller one over. Now you could have moved and subtracted 40M from both sides, but you'd be left with a -5 over here. Okay, so +5 or -5 really depends on your personality and the way you do math. But how I do math is I like to stay away from the negative coefficients because it just means it's another opportunity to make a mistake. So I don't have variables on both sides anymore. I do have addition on the same side as my variable. So I'm going to subtract 75 from this side. 100 minus 75 is 25. Still less than 5m. And the variable still is not by itself. I need to divide both sides by 5. Those cancel, become 1. So m, 25 divided by 5 is 5. So 5 is less than m. What does that really mean? Well, we have to do the flip-flop. Remember, we want our variables to be written on the left, so we have to read it backwards. If I read this backwards from right to left, it says that m is greater than 5. Okay, so that means that after 5 months, gym A will be less expensive than gym B. So that is my answer as a sentence. After 5 months. 5 can look like S's sometimes. After 5 months, gym A will be less expensive than gym B. And that's the final example. So you're ready to move on to the practice problems in your textbook.